Hello everyone. In this video we are going to examine the anatomy of the ear and discuss the functional anatomy of those structures as we go along. Before we get into things, please keep in mind that the ear is involved with detecting two distinctly different senses. One, it detects sound, right? That's the intuitive one. We know that we hear with our ears. But the ears also are responsible for our sense of equilibrium. Right? Equilibrium kind of comes in two different forms. There's what we call dynamic equilibrium. Dynamic equilibrium is our ability to detect changes in rotational and linear acceleration. For example, if you got in a car and closed your eyes, you would be able to know whether you were accelerating or decelerating, or turning to the left or turning to the right, or going up a hill or down a hill. That's dynamic equilibrium. Your ears are involved with sensing that. Static equilibrium is the ability for you to detect your body position relative to gravity, or more specifically, your head's position relative to gravity, since your ear is located in your head. For example, if you closed your eyes, you would still know whether or not you were lying face down or face up, or on your left side or right side, or whether you were upside down or right side up. Right? That's referred to as static equilibrium, and the ear is involved with that as well. This is an ear cut open in coronal section. Right? And the ear is divided into three main regions. There is the external ear, and the external ear includes the auricle, right, which is also sometimes called the pinna. Right? This is the obvious part of the ear that we see on the sides of one another's heads. Right? Then there is the external acoustic meatus, right, also sometimes called the external acoustic canal, right, or external auditory canal. This is you might remember this from the skull lab, right? This is the deep passageway into the temporal bone. So this is the same structure, except here we're seeing it lined by skin. Right? The external acoustic meatus ends at the third part of the external ear, a circular or oval piece of skin known as the tympanic membrane. And the tympanic membrane basically separates the external ear from the middle ear that we'll look at next. Before we move on to the external ear, just some functional things that are going on here. The external ear is involved only with the collection of sound. It doesn't have anything to do with equilibrium. Basically, when sound waves travel through the air, they are collected by the pinna, which acts like a funnel, directing those sound waves down into the external acoustic meatus. At the end of the external acoustic meatus, these sound waves hit a dead end, which is the tympanic membrane, and the sound waves are going to push on the tympanic membrane. The external acoustic meatus is also lined by it's lined by skin, but in the skin there's a modified gland known as a ceruminous gland, which produces a waxy material known as cerumen. This is what produces the wax of your ear, and that wax creates a protective coating over the skin that keeps the skin pliable and moist and reduces the likelihood of infections. Let's go ahead and talk about the middle ear. So the middle ear the middle ear begins where the external ear ends. So the middle ear is basically an air-filled space between the tympanic membrane and the temporal bone. So there's a space right there. That's the middle ear. Okay? In addition to being filled with air, there are a series of three bones known as ossicles, right? Which translates little bones. Those three ossicles are the malleus, the incus, and the stapes. Right? The malleus is connected to the tympanic membrane, and then again connected to the incus. The incus in turn is connected to the stapes, and then the stapes interacts with the inner ear. It actually covers up an opening on the inner ear known as the oval window. Functionally, what's going on with the inner ear is that the sound waves that cause the tympanic membrane to move back and forth will cause the ossicles to move back and forth. Right? And so what's happening is the tympanic membrane, together with the ossicles, are converting sound waves into motion. Right? And so as the tympanic membrane moves back and forth, the ossicles will move back and forth, which means that the stapes is going to push in and out on the oval window. In order to do this, the tympanic membrane needs to be able to move freely. Right? In order to move freely, the pressure on its inner surface and the pressure on its outer surface need to be equal. And so there needs to be a way to make sure that the air pressure on the outside of the tympanic membrane is equal to the air pressure on the inner surface of the tympanic membrane. And that's where the auditory tube comes in. The auditory tube, also sometimes known as the pharyngeotympanic tube, because it goes from the pharynx to the backside of the tympanic membrane, is a passageway that allows air to move from the pharynx, which you can think of as your throat, into the chamber or space of the middle ear. Right? One situation where this kind of comes into play that I think a lot of people can relate to is if you go in an airplane or if you go up to the mountains, you'll notice at some point the sounds kind of get muffled and you can't hear things very well until all of a sudden pop and you can hear things, right? So if you're familiar with the sensation of your ear popping, what's happening there is as you go up into an airplane or as you go up into the mountains, the amount of pressure on the outside of the eardrum is going down relative to the pressure on the inside of the eardrum, because as you go up in elevation, air pressure decreases. Now, the auditory tube is not held open. Down here where the pharynx is, it's kind of got this slit-like opening, and it kind of gets pinched shut and covered with mucus. And so air does not freely circulate on an ongoing basis in and out. There needs to be a slight pressure buildup. And then once the pressure on inside here is significantly different than on the outside of your body, then the pressure difference will kind of force the slit open and the ears pop. But what happens is, for example, if the pressure on the inner surface of the tympanic membrane is higher than the pressure on the outer surface, then what happens is when sound waves hit it, they're coming up against resistance that prevents the sound waves from moving the tympanic membrane. And that reduces the movement, and therefore it reduces the movement of the ossicles, which then causes the perceived volume of the sound to go down because it's not producing as strong of a stimulus, because the tympanic membrane is not free to move. When we look at the inner ear, the inner ear has three basic parts. Okay? The inner ear is made up of the cochlea, and the cochlea is this portion here that looks like a little snail shell. Okay? It's also made of the semicircular canals. Okay? The semicircular canals are these loops that you see here. Right? They are actually oriented in three different planes. Right? So if you're familiar with like an XYZ axis, each one of these semicircular canals is oriented on a different plane. One is oriented vertically, another horizontally, another running forward from anterior to posterior. And then between the cochlea and the semicircular canals is an area right there known as the vestibule. All right. The vestibule and the semicircular canals are involved with detecting equilibrium. The cochlea is involved with detecting sound. Okay. The sensory information that's collected by the inner ear travels to the brain through the vestibulocochlear nerve, which in the old days was called the auditory nerve. Okay. Keep one thing in mind, that when we look at this image, or most images in textbooks, it makes it look as if the inner ear is a solid object that you could reach into the skull and pull out. Well, in effect, what we see when we see the inner ear is this is really just the shape of a space inside the temporal bone. The inner ear is housed in just a weirdly shaped space in the middle of the temporal bone of your cranium. Right? In the next video, we're going to look at the details of the inner ear.